Hey, in today's video, I'm going to be going over the teacher notes for day 3 of transforming random variables. And our context for today is it time for a raise? After you've been working so hard, I've decided that you deserve a raise. Now, I can't decide what type of a raise I should give you. Either I'll give everyone $10 or I will double everyone's wage. I would like for you to copy your data from yesterday's class and use that to answer through questions 3. You should be able to find all of this using the equations that we found this unit. They are on your formula sheet or in your notes, and then answer through these 3 questions and come back for the answers, the teacher notes. All right, if you're ready to go over the teacher notes, at this point you should have done the problem yourself. Let's get started. So for number 1 here, I have my probabilities copied from yesterday. This is from my own data, not from your specific class, so yours will look a little bit different than mine. And I've got the mean from yesterday and my standard deviation from yesterday. In 2A, now this is where I'm adding $10 to every employee. So instead of $1 an hour, you make 11. Instead of 5, you make 15. All the way up to 25 becomes 35. So then I've copied the probabilities. These should still stay the same as above because it's the same person who used to make $1 is now going to make $11. And then I calculated the new mean and standard deviation. And if you notice, if I compare the mean that I have for 2A to the mean I had in number 1, it is just the old mean plus 10. Now the standard deviation is exactly the same. So what happened here is we added $10 to every single wage. We have shifted our data. So we created a shift in the data, and we see that the mean has shifted up with the data, but the range, the standard deviation, has stayed the same. Still, between 11 and 35 is the same range as there is between 1 and 25. So the spread of our data is the same, but the center has shifted. And so that's what I wrote here. When we add, the mean increases. It shifts with that increase that we added by, but the standard deviation does not change. Now, for option number 2, I filled in the new wages. So if you made $1, now you make 2, all the way up to if you made 25, now you made 50. These probabilities, again, are still the same. And I've calculated the new mean and standard deviation. Now, if I compare these back to the original mean and standard deviation, I notice that the 1680 is just 2 times that old mean. And the standard deviation, this time it has changed. And if you tried it, it is 2 times the old standard deviation. So how did the multiplying by a constant affect the mean and standard deviation? Well, both mean and standard deviation were multiplied by 2. So what happened here is that when we multiplied by 2, we expanded our data. The variability has also changed now. From before, I went from 1 to 25. Now I'm going from 2 to 50. I've essentially doubled how large the range of values is. So which option would you prefer? You could have any answer you want here. I just said if you had $1, $5, or $7 originally, you might like option 1 better. Or if you had 15 or 25, you'd probably like option 2. All right, so getting to the important ideas for today. This is all about transforming probability distributions. We have 2 types of transformations that we are doing right now. That is to add and subtract a constant, which we will call C. When you simply add or subtract, the shape stays the same. The center, we add or subtract, it shifts with the data, and the variability stays the same. When we multiply or divide by a constant C, the shape stays the same. The center will multiply or divide by C, And the variability will also multiply or divide by C. If you remember, we did talk about this before in a previous unit, how the shape stays the same, the center and the variability sometimes change. So still works the same as before. Complete the Check Your Understanding to be preparing for our upcoming quiz, and I will see you later.